So now we're going to put all that information together, what we learned about in the anatomy and the features of the atoms. We're going to use that information to try and draw an atom from scratch. Now on screen here I've illustrated what I think is a very simple, a very basic type of question. I would expect to see something like this on a test to some extent. So let's get started. What can I do to get started? It's asking me to draw the carbon atom, and I've just gone ahead and taken a slice out of the periodic table and put it into the question here. You might have a periodic table to work from and just to look for carbon itself and take the information you can. Here I just got it on screen. So I know that I can start working with, I need three quantities. I need the protons, neutrons, and electrons. If I have those quantities, I can draw an atom, no problem. So proton count, easy to find, it's here, number 6. Therefore, 6 protons. I use the feature that all atoms are neutral if it hasn't been specified to be positive or negative. So therefore, to balance out those positive charges, I must have 6 electrons as well. Let's find the number of neutrons. Very easy. Take the mass number or relative atomic mass, and I'm going to round it to the nearest whole number, as we mentioned, for our intents and purposes. If I find the difference between the mass number and the atomic number, I should find the number of neutrons. So 12 take 6 protons is equal to 6 neutrons. There we go. 6 protons, 6 electrons, and 6 neutrons. Very simple. Not all atoms will have equal quantities of those 3 items. They will vary in most occasions, but in this one it just happened to be a lucky choice where all of them are 6. Let's go ahead and start drawing. If you've left your pen at home, let's say you've got your blue and red and purple and all kinds of funny colors, if you're a bloke and you don't bring colorful pens and you've got to try and draw protons and neutrons in the middle, remember how I've been using black and blue to denote those 2 different quantities? If you haven't got that, here's what I recommend. Use a circle with a plus sign to represent the protons and an empty circle to represent the neutrons. And you can do that, and you can use those to build up the nucleus if you haven't remembered to bring a set of colorful pens. Here we go. I have to have 6 protons now. 1, 2, 3, 4, 5, and 6 protons. How many neutrons? 6. 1, 2, 3, 4, 5, 6. Good enough. Now I'm going to start drawing my electrons onto it. So I'm going to put my shell on there. How many electrons fit in the first shell? 2 a maximum. I've got 6 in total to work with, so I've got 2 put in there. I've reached the maximum, have to go to the next shell. Next shell can have a maximum of 8. I probably don't have that many, so let's just use what we've got. So I've used 2 so far, 3 so far, 4, 5, and 6. I've used all the electrons, and therefore that's my diagram. Again, go see this video about electron configurations. You can learn more detail about how they're arranged on the outside and the process that you must use to do so. And last thing that I'll do before I call it absolutely done, I'll probably go the extra mile to communicate to my teacher what color means what. So on the outside here, these dots here are my electrons, and these blue dots are my protons, and I would also point to the black ones for my teacher. These are my neutrons. Okay, there you have it. Very simple and quick and easy to do. If you watch my video on electron configurations, there's a trick. You can find a bunch of extra tricks to figure out what the configurations are just by looking at where the element is on the periodic table. But besides that, this is a very basic skill, and I'll catch you in the next video series. Thanks, bye.